Hello friends, in today's class we are going to talk about another classical synchronization problem called readers writers problem. Welcome here, and I'm talking about a new problem, that is readers writer problem. And to define the reader writer problems, we processes share resources. Okay, and this resource particularly we are talking about files and record. And there are few processes which only wants to read the file. Okay, and if more than two processes reading a file simultaneously, then it has no impact. Okay, it is okay. Okay, then it's allowed. But if one process reading a file and another process updating the file, then it may result in adverse condition. Okay, and that is nothing but your inconsistency may occur, right? So inconsistency may occur, and this we cannot allow that one is reading and writing simultaneously. One is reading the file, another one is writing the file. This cannot be allowed, and this is called as a readers writer problem. Now, the solution of this reader writer comes in several variation and all involving priorities, right? And the first is this is the first version, and it says that no reader be kept waiting unless a writer has already obtained the permission to use the shared object. Okay, so readers should not wait here only because writer has access or granted permission for accessing the file. In other words, no reader should wait for others reader to finish simply because the writer is waiting. Okay, so the idea here in this case, if there is a file and one is reading, and already a writer has already obtained let's say permission to write the file, and in between another reader comes, let's say R2 comes, R2 cannot deny the access only because the writer has already obtained the permission, and that means readers are given priority. Okay, second readers writer problem can be here that the second reader writer problem requires that once a writer is ready to perform write operation, that writer perform its write operation as soon as possible. Okay, in other words, if a writer is waiting to access the object, no new reader may start reading. Okay, so once it is waiting, someone comes as a writer, then it has to perform as soon as possible. Okay, and that means here writer is having the writer's priority, right? Now, so what is the implication here? That in first solution, both the solution will result in starvation, denying of the resource indefinitely. In the first case, writer may starve for the resource, and second case, reader may starve for the resource. And for this reason, other variation of the problem has been proposed. Okay, but what we are learning here is the first variation. Okay, that where readers are given priority for no reason we are reading that just one classical synchronization problem, and we are reading the readers writer where readers are given priority. So these are some summary for this whatever just now we have learned. Data is shared among the number of concurrent process. Reader is the only read the data set, do not perform any update. Writers can do both. Problem is that allow multiple reader to read at the same time on only single writer access the shared data at the same time. Shared data is your data set, the file, the semaphore WRT initialize 1, mutex initialize to 1, read count initialize to 0. Right. Okay. WRT is a binary semaphore, and it will shared among the readers and writer, and it will allow only one writer at a time. Okay, that is the responsibility of your write. Mutex is a semaphore that is used for that concurrent mutual exclusion when read count is being updated. Okay, read count is updated. Okay, so that is used by mutex, and read count is the number of readers. Okay, so that is the different variable that we are going to use. Writer WRT is a semaphore that has been both WRT and mutex initialized to 1. So this is the structure of a writer process, that if a writer will just say wait, and if it is the first one to execute this wait WRT, then it will make this WRT wait. That means it will become 0, and it will perform the write operation, and on exit it will just signal, and that will make it WRT back to 1. Readers. This is the structure of the readers one, and first it will log the mutex will become 0, and mutex is only in the reader, so other readers has to wait. Okay, if another reader also say wait mutex, then this will stuck over here. Okay, this another reader, so this is suppose reader 1 and this is reader 2, so this will stuck over here. Then it will update the read count, and the moment reader has decided to read the file, then it will execute the wait WRT. Okay, if the reader count, the first reader it will do this thing, that it will lock the others writers to not access the file. The first reader will lock it. Then it will signal mutex. The moment signal mutex will occur, another reader will go, and another reader will do what? Read count. It will increment plus. Other readers will not execute this wait, because one time already had this has been done by the first process. So it will not execute again. First time, only the first time this will be done by the reader. Second, no, not required actually. Then it will signal the mutex, and that means another reader can also come and update the read count. So for the first reader will block the writer here for this statement, and otherwise they will just update the read count and can start performing the reading. Okay, so if the writer is the first one to come, then only it is okay. Otherwise, if reader is there, that is going to perform blocking operation for this writers. Upon exiting, it will perform this wait mutex, and read count will be updated, and it will check, every reader will check if read count is exactly equal to 0, indentation problem is there, then it will just say signal WRT. Only in that case it will allow the other reader to go and the writers to go and write the file. Signal mutex only for this. But this will be done by every reader. Every reader will do this thing. The moment it will find that okay, if it is find that read count is 0, then it will just signal the writer here. Okay, so that is your reader's writer, one of the solution where here reader is given preference and writer may starve in this particular case. Okay, so that's all for this discussion. I hope you understand this. Thank you.